Thank you all for being here and the organizers for inviting me. It turns out that this is an appropriate talk to have a fanfare of trumpets bring it beginning. I'll tell you, it's work I've done with David Hockney, much of what I'm talking about, some of it not. And what I'm going to do is an outline in the next 70 minutes of my talk. I'm going to talk fast. And so for those of you who want to download papers, read more about what we've done, I purchased at no small cost to myself the domain name art-optics.com. And then I'll just bounce you to my university URL, which is too long to remember. And since always in an audience somebody's dyslexic, I also purchased optics-art.com. So either one of those, you can go there and you can read everything. So we talk, I'll have an introduction, background. I'm going to give one example today of early optics in art to show you the level at which we can actually analyze what goes on in some paintings. And then I'm going to teach you art history. For those of you who are art historians, I'm going to teach you 600 years of art history of optics and art in this talk. And then I'm going to go on to some more recent work on scaling and what I'll call nonlinear time. And you'll see what that means. And then every talk needs to conclude eventually. So as an introduction, that I've taken the organizers' words quite literally, bringing together physicists, mathematicians, art historians, and so on. And I'm going a little bit further. I'm going to talk about some of the pitfalls and pleasures of doing interdisciplinary art. So speaking more broadly than just to the audience of people that are in the room. Many of you, maybe all of you know this, but in case you don't, David Hockney, two respected dictionaries of art and artists, best known, most critically acclaimed British artist of his generation, or American artist, depends on what country wants to claim him. His drawings and etchings are amongst the deftest of this century, maybe the greatest of modern portraitists. You don't have to believe that if you don't want. You can say he's the second greatest, the 10th greatest. But his skill as an artist was essential for making the discoveries I'm going to talk about.
David Hockney, our most celebrated living artist.
He is considered to be one of Britain's greatest contemporary artists.
His originality and skill have ensured his success from the beginning of his career.
But what's important for my talk, great, just died, is...
I admit, for instance, I am interested in pictures. I keep saying this. I'm interested in how you make pictures.
Throughout his entire career, if you look back at books he's written, he's been interested in how paintings are made. And so he's had a certain curiosity, an intellectual curiosity, that actually is atypical amongst many people. And so we made discoveries, and I'm just going to show this one thing, about paintings that are in art museums, the Hermitage, the National Gallery, various art museums, that if you believe the directors of those museums, and you probably shouldn't, 25 million people a year for year after year have looked at those paintings, and we made discoveries about those paintings that was not known before. So you should pay attention to what I say, because I'm saying, maybe I'm wrong. I'm not, but you should pay attention. And not in just minor paintings either. The Arnolfini marriage, and I'm going to talk about that chandelier a little bit later. This French ambassador's, the Hans Holbein, that painting is as large as that screen. And there are features I just don't have time to talk about today in that I can show you were based on optical projections. And a number of conferences have been organized, 3 specifically about this work. I warned you, I'm going to talk fast. So the image formation process is an important one. The image formation process, if a lens is used to project an image, there's a lens, we have some scene, pattern recognition using computers to solve sensory problems. And so if you look at books on written by scientists, computer scientists, and so on, you'll see words like modulation transfer function, image segmentation, and so forth. But the actual, and I had an assistant go through every book in my library, the university library, that had something to do with image analysis, and they were written by people with in departments of electrical engineering, applied math, psychology, disciplines that are not necessarily known for skills with image analysis, let's say. And there's a difference between imaging and painting in the sense that all of physics fits in a book this size. An equation describes all sorts of things. The paintings from a single century in a single art museum fits in a book of the same size. So there are differences between painting and physics. But the image formation process is the artist sees that image in their brain now kicks into overdrive. The quality of the painting depends on the dexterity of the artist. This is what a projected image might look like, but this is maybe what the artist would paint. We as humans recognize that as a human, but that doesn't look anything like a human. And so words, instead of modulation transfer function and stochastic detection, form, texture, shading, these enter into painting. So there are differences, not subtle differences. So my background, which is important for understanding, and I'm going to give you my background as of the time I met David Hockney 25 years ago. Well, first, this is actually a small piece of my lab that I had, that I work in a completely different field than image analysis or painting or anything. That's a molecular beam epitaxy machine, and it's high tech. My graduate students are dressed like ninja warriors. But this article in the New Yorker, an efficient test of where you stand on contemporary art is whether you're persuaded or persuadable that Chris Burden is a good artist. I think he's pretty great. Chris Burden is best known for a performance art piece he did in 1971 on the Inside Shot. Now I'm going to show you a 50-second clip that Chris...
This film was shot by one of the participants from one of the ladders that you've just seen. The piece consisted of lining the gallery with black plastic and then flooding it with about 12 inches of water. 3 other people and myself waded through the water and climbed onto these wooden 14-foot step ladders. After everybody was in position, I dropped a 220-volt electric line into the water, thereby sealing us in, because if we came down off the ladders and stepped in the water, we'd be electrocuted. The piece is already in progress. It began at midnight, and it was to run to 6 o'clock in the morning.
That's me. So I've been involved in art, in contemporary art, for a long time. And I'm going to show other examples of this. So at the time, I've been doing all digital photography for the last 20 years or so, but at the time I did film photography. This is only a small fraction of the lenses that I own in film photography, ranging from super wide angle to super telephoto, macro lenses, lenses that distort, let's say, reality in a sense, like fisheye lenses. I can curve the field that is projected on the image, on the image plane, on the film, put in variable amounts of spherical aberration, anamorphic lenses, shift lenses. So I was very familiar with everything you could do with a projected image, photography being a projected image. And at the time, it's been 40 years now, at the time my stock photography had been represented by an agency in New York for 20 years or so when I met David. So my publications, somehow, I went from ultra-thin cobalt films to evolution of the motorcycle. And I'll tell you about that in a second, more. And then a few years later, I'm still doing secondary ion mass spectroscopy, and then work with David. So the Guggenheim in New York put on an exhibition in 1998 called The Art of the Motorcycle. It set an all-time attendance record for the Guggenheim, and it was a sculptural exhibit, an exhibit of industrial design. I was the co-curator of that exhibition. So let's go over that quickly. And I actually won an award with Frank Gehry, who's arguably one of the world's best known living architects. And this workshop has to do with scale. One of the reasons why I think it's so successful, or was so successful, was when this was the Guggenheim Las Vegas, Frank Gehry design, that on a scale you're seeing here of 2,400 square feet, it's interesting. There are interesting things to see. You see a motorcycle, 24 square feet, it's still interesting. You look at individual components on a motorcycle, it's still interesting. So over a wide range of scale, the closer you get, there are still things that caught people's attention. So I'm going to show you one example, and I'm going to go through it fairly quickly. Complex features due to refocusing, a painting that was done 75 years before Galileo. Art historians might say at the time of Galileo was the first time images could have been projected, but artists did not use lenses. And I'm going to show you if an art historian said that, they are incorrect. But this is 75 years before Galileo anyway. So David had collected together all the paintings that looked to him worthy of further consideration, and he organized them on a wall the length of a tennis court in his studio in Hollywood. And he organized them chronologically with paintings from Northern Europe on the upper wall, Southern Europe on the lower wall, like the physicists in the audience or the chemists in the audience, like Mendeleev putting together the periodic table. What's happening here, at what time, are the things that can be learned from that. And one painting caught my eye, this one. And so when I got back home that day, I faxed David. Everybody here is young enough to know what a fax machine, or old enough to know what a fax machine is. And I faxed David and said, what was that painting? He told me, and I'm going to talk about this painting, and I'm going to talk about a feature in this painting, that central octagonal pattern. It looks like it goes out of focus. Well, at this point in our life, everyone in this room has seen a billion images. So that's, perfectly reasonable. Except that's not, if you'd never seen a projected image, this would not look reasonable at all. You would have seen these wine bottles in focus. You would have seen that car in focus. And your brain wouldn't have bothered telling you that in between, it had caused the muscles in your eyeballs to contract, to refocus, and your brain would have constructed an image that was entirely in focus. So this is our first strong clue that optics may have been used. Again, I'm going fast. Go to art-optics.com. If I take make an octagonal pattern roughly the size of octagonal patterns that were on carpets of this time, I'll take it, I'll try to perspective correct it, and I'll put it in color in a second for reasons, and I try to lay it on top. It doesn't fit at all. But as I knew as a photographer, this is a large object at a fairly close distance. Depth of field comes into this. And so I'll simulate with Photoshop what a single element lens looks like. I see the front in focus, the rear is out of focus. But let me, I've got this projected in front of me. I'll trace in the front, and then I'll refocus. Counterintuitively, if I'm focused on the organizer, and I change my mind, I want to focus on the back row, I actually have to pull the lens toward me to focus further away, which reduces the magnification. In an ordinary camera, your iPhone camera, this is a negligibly small effect. In a large camera, an 8x10 view camera, it's a huge effect. So I refocus, I trace in that part that's in focus, I refocus again, and I do the back. And I'm going to show you more in a second. So now I've got the whole thing in. It turns out that there's the full painting. The distance across that woman's shoulders is 10 inches. Distance across a real woman's shoulders is 18 inches. I know this because I have a wife and 2 daughters. So I measured them. Normal people think this is a bizarre thing to do. Spouses of physicists think this is a perfectly normal thing. So that means I've got a nice geometrical pattern here. I've got repeat distances in the back. I know the depth of field in real units, so centimeters. And so there are 2 equations from geometrical optics that come into play. I'm going to use that. Told you I had to refocus twice. I've got the magnification in the front, the depth of field in the front. I've got 6 equations and 7 unknowns. If I were giving this lecture in the mathematics department of Oxford, I wouldn't have to tell you this, but I'm at Cambridge.
This is it. That moment they told us about in high school where one day algebra would save our lives.
So, the scientists, the mathematicians in the audience know if I've got 6 equations and 7 unknowns, if I make one assumption, everything else follows. I've got no other choices on this matter. And so I'm going to tell you that I'm going to assume that the tablecloth, or the carpet is about 4 feet away, 1.5 meters for Europeans. It's the assumption, it's robust to that assumption. I could make the distance a little bit different, makes very little difference. So, 1.75 meters, sorry. So geometrical optics dictates that if a lens was used by Lorenzo Lato, there have to be 3 different magnifications, 3 different sets of vanishing points. And so if I refer to that as my distance from that kink to that kink, after I refocus, that distance changes by 13.1%. Algebra tells me it should change by 12.6%. It agrees with the laws of geometrical optics to 0.5%. Refocus, again, it agrees to 0.5%. Now, an important thing, Ellen Winters said this, a psychologist said this at a conference, which it clarified. I didn't understand why some people weren't understanding this. So we're not saying that optics are the only way to get perspective right. We're saying optics is the only way to get perspective wrong in precisely the way they got perspective wrong, to within 0.5%. I took an infrared photograph at the Hermitage, and you can see very clearly, visually, nice clear tracing lines. After he refocused and the magnification changed, oh, I gotta go back, what happened? This does not let me go backwards. There we go. After he refocused, when you refocus a geometrical pattern, things don't line up anymore. Here he struggled to make things line up. He refocused again and he gave up. And so an art education student did an internship with me. Here's to scale that central octagonal pattern. What he's going to do is he's going to take one lens of a pair of spectacles and project that image onto a piece of transparent plastic, and then he'll paint that in. And I'll jump ahead in a second. So you'll paint the region that's closest to the front of the projected image first, jump ahead, and then he'll refocus. And you can see it come into focus right there. So he'll paint the intermediate region after he had to refocus because the depth of field is so small. And by the way, they had spectacles back then. They had spectacles for 100 years before Lorenzo Lato. And then had to refocus again. You complete it. And when he takes it, he'll put this piece of transparent plastic on a life-size copy, a 1-to-1 reproduction I had hanging in my lab. And it fits perfectly. So did Lato use a lens? Of course he did. A cautionary tale. So, especially for interdisciplinary research. Here, these two, David Stork, who's speaking at this conference, said that a lens couldn't possibly be used because of all these lines that he drew. Well, you don't draw those lines if you understand photography, that you have to refocus. That this is just wrong. From an art history textbook, here the point of view the camera, of our viewing, is above the house. So we draw perspective lines that go to a vanishing point at a height, at a horizon line, the height at which the lens is above the house. The Arnolfini marriage, the chandelier, were below the chandelier, so the vanishing point should be below. Again, in a peer-reviewed publication, peer review is problematic as it is. It's especially problematic in an interdisciplinary area where you have people who are trying to evaluate things that aren't necessarily in their field of expertise. And he said that clearly a lens was not used because the vanishing points don't come to a line. Well, here's a chandelier, a real honest-to-God chandelier of the size that I calculate is in the Arnolfini marriage. And I took the photograph myself, so it's lens-based optical projection. And the lines don't come to the nice, clean vanishing point that this oversimplified view of perspective would tell you should. And they don't, because if these arms are just displaced by a millimeter or so one way or the other, looks perfectly good. You pay a few $100s to buy that chandelier. But when you extrapolate things that are off by a few millimeters, they don't come. So again, if you understand in the real world that this is just not reality, you get things wrong. And so lots of evidence, read my paper. But in the end, what we can show you is that Lotto used direct optical projections to aid him in less than 6% of the surface area of the painting. If you analyze that dog, you decide, well, he didn't use a lens to project that dog. Well, you analyze the wrong part of the painting. That no matter what, paintings are not images that are projected fixed by paint. Portions of them, where they aided the artist, are optical based, other parts are not. So if artists started using optics circa the time of Jan van Eyck, which I haven't shown you, but you just read my papers, when did they stop? I'm going to show you a visual history of optics-based paintings, meaning portions of them made use of optics. They're going to be in chronological order, all by name brand artists. And they'll go by faster than I can possibly name them. So I suppose if you've ever taken an art history class, you'll recognize these paintings go by, but they'll go by faster than you can even name them, because I'm going to show to you in 18 seconds. And so if you blink, you'll miss a century of art history. So there we have already going by too fast, memory, too fast, even me. All of these have elements in them that are based on optics. So they started using 1425, never stopped. This is the direct use of optics. There's a whole nother talk about the indirect use of optics. Once you've seen optics used, once I've taken this scene and I've projected it on canvas and I've learned the laws of perspective, somehow this is ingrained in my memory. So it's hard if you don't let me project this scene. I'm still going to draw vanishing points and vanishing lines. And so that's the indirect use of optics. And David has painted my portrait 3 times, and I'm going to wager that I'm the only person in this room whose portrait has been in the National Portrait Gallery. So eat your heart out. David visited my lab. This is an electron microscope that's in my lab. And one thing about an electron microscope is that electrons are sent down through the sample onto a fluorescent screen. And so you see the fluorescent screen, you focus everything, and then you take a photograph of it. This is what he was seeing. Of all the people that have ever been in my lab and ever looked at a transmission electron micrograph, David is the only one who commented on the shade of green of the fluorescent screen. So now, totally lost track of time, so time is meaningless. Time is relative, Einstein told us that, so I'm going to ignore that. So I gave a talk at the National Gallery of Australia, and This is his painting of the Grand Canyon. So we're going to talk something about scale. He painted this on a number of canvases. But David then got interested in the moving image. Now, let's say you've got 3 movie cameras. How are you going to aim those movie cameras? I'm going to mount these movie cameras on a top of a car. I could aim them all straight ahead. I could aim them so they converge. I could aim them so they diverge. There's a lot of things that you could do, a lot of variables in this. And so David and I spent a lot of time talking about this. If it's a movie camera, you could have them all running together, but when you play it back, you could play back this scene 5 minutes ahead of the others. So you've got time as well as space to manipulate. And I'll show you, this is, these are 48 inches, so 4 feet across. So it's like 25 feet across. I don't know, roughly the front of this room of all high definition television screens. And in a second, I'm going to walk up to it. Just remember this little area here, a small fraction of one screen.
So the wheelchairs are really useful for that.
This isn't his most interesting one, but I use it because this is one where I walked up to the front of
You
it.
just come up and look at a screen.
And it maintains its fidelity because it's high definition. And eventually my camera goes out of focus. So it's not that the tree leaves are out of focus, it's my camera won't focus that close. So it maintains its fidelity when you look at it from across the room to up close. The scale mattered in how you interact with a display like this. I like this because this is a selfie that works on multiple levels. This is the, David's in front of me, a mirror's in front of me, the latest paintings he's doing are behind me, and so this is my selfie in the mirror of his paintings and of David.
Here's what's so revolutionary about what you're saying. You're saying the history of art, the history of the Renaissance, is the history of optics.
I am saying
I know that,
yeah.
and you're blowing everything up. You're blowing everything that all of us who took art appreciation studied, all the art historians have written, and you're saying you're all wrong. It's all about optics.
Art historians haven't liked us for that.
This is the end.
So thank you for your attention. I hope I didn't speak too fast. art-optics.com. I'll be happy to answer all your questions. I could have gone slower, but I had a lot of images. I could have talked slower.
11 minutes left.
Oh wow! I could put more in that. Wait, 11 minutes of my talk, or including questions?
Talk. Yeah.
Talk.
Okay, so just hang on. Let me.
10 now, but you know.
We'll get there. Just I want to show you a Van Eyck, something that I did take out. Yes. So one of the nice things about collaborating with somebody like David Hockney is you get to see the Ghent altarpiece all by yourself for 6 hours. But there was a cameraman, a soundman, and a director, and we were able to look at the Ghent altarpiece. And so I got interested in that. This is the entire Ghent altarpiece. It's huge. If you haven't seen it, it takes up a lot of area. So I'm going to take the central part of this and I'm going to enlarge it. I'll enlarge it again. I'll enlarge it again. And I'll enlarge it one more time. So features that are 1.5 inches across have the individual threads visible in them. So Van Eyck has covered every square inch, just like David Hockney did with his moving images. Every square inch of that painting at that level of detail. You can see the individual threads going in and out. So again, on the subject of scale, Van Eyck understood the power of having something where you could stand back and you could look at a powerful Gantt altarpiece, but you come up and it's not like it goes out of focus or gets blurry on you. He understood that you wanted, that maintaining that had an effect on the viewer. Let's see what else I've got there. That was it. How am I doing for time now?
8 minutes.
Okay, so I actually kept lots of stuff in my PowerPoint in different orders so that I can, let's see.
Charles, maybe give us another example where you've used optics to show that optical principles, to show that optics was used.
I'll have to pull up a different talk. Hang on.
Well, you gave us one example.
Well, no problem. I just have to, no, here we go. We'll try this one. And move down. Hang on, it's we're almost there. The French, Hans Holbein, the French ambassadors. So those of you probably all have seen this, but a lot of people haven't. It's interesting, when I give this to a general audience, I say, what is this? And the number of people that recognize that is a anamorphic skull is negligibly small until I rotate it into position. Oh, wait a minute. Ignore that. So when I rotate in position, people go, ah! Yeah. So it's funny to me that people, I mean, it's just obvious to me that that was a anamorphic skull, but most people who have not seen it before don't recognize it. But me being a physicist, I look at this and I go, that's a really bad skull. I mean, it's a skull, great, but it's a bad skull. Well, how could he paint that skull and still have it a bad skull? So let's take that skull, magnify it, and there's a real skull. If we look, the real skull versus this, here the jaw is too long, the bulge back here, and he's got this sinister eye looking at you. How did he manage to make that? So what I'll do, there's ways of making anamorphic images. You could take a regular image and draw a grid, make a nonlinear grid, do a one-to-one correspondence. But when you're done with this, if you went back, you'd return to the original image you had, subject to whatever errors you made when doing the transcription. Here's the Holbein skull, and there I'm going to reflect its and focus its image using a concave mirror onto a screen that's at an angle. So it'll take a circle and it'll make it elongated. And I'll take a picture and I'll show you a skull. Well, when I try doing that, first, let me get the mirror out. This is the perspective we should expect to see from the mirror once I take it out of the ring stand. But I immediately discover depth of field. It doesn't work. So, but what I'll do is I'll do what Lorenzo Lotto did. I'll paint in the part that's in focus, and at that point, that's the only part of the screen, the canvas that's being painted. I'll refocus, and then I'll paint in the teeth. And I'll continue doing that. When I'm all done, let me straighten it up and then compress it. The jaw is too long, there's a bulge back here, and there's that evil, sinister look. And if you look more closely, you'll realize he made a mistake. It's easy to do this. This feature and this feature at the same depth were duplicated. He made that mistake. what he really should have painted is something that looked like this, which still doesn't look like a skull. The magnification is linear in this direction. 1 over sine of the grazing angle. Again, if I were at the Oxford University Mathematics Department, they would understand this. But here I'll explain that if you know how to solve a piecewise segmented nonlinear transformation, that's another way he could have done this. Or he just did it by projecting images. Okay, so I must have used up my time by now, or close. Still? Still close.
It's close enough.
Okay, close enough.
But you have 3 minutes. What do you...
Let's add it to the discussion.
Okay.
So let's start the discussion. And thank Gregor, yes.
Thank you. Great talk, Charles. I was wondering, a couple of months ago, I had the opportunity to talk to Tim Jennison, who did Tim's Vermeer, and he showed that he painted, or he repainted the Vermeer's music lesson with optical instruments, and now he did another one with the View of Delft, also with optical instruments. And he got a strong backlash from the artistic community, saying that's kind of blasphemic, showing that Vermeer used his techniques. Did you experience the same thing?
Oh, I'm surprised I haven't been burned at the stake. Seriously. So one of the first places David and I spoke was at the National Gallery in Washington, D.C. And before we spoke, the director had us and his senior curators for lunch. So we're sitting around a room, and the director asked the senior curators, what are you hoping to learn from what David and Charles are going to say today? And one of the curators, bless her heart, was totally honest. She said, I'm hoping to learn that everything they're going to tell us is wrong because these artists were such geniuses with skills beyond anything we could imagine that they wouldn't have needed to use optics.
Yeah, but does this diminish the genius? Because if you use the optics, that's really...
So anybody who believes that, I defy them to focus an image with a single concave mirror onto at a large scale that you have to refocus. It's difficult. It's really difficult. Now, it does make things easier. Like if I were wearing a paisley shirt, and somebody wanted to paint my portrait, they would say, "Leave your shirt behind," and they could project and get the paisley shirt just right. But Lotto had the skill to paint a dog. It's a Bichon. It's recognizable today as the breed very easily. So he had the skill not to use optics where he didn't need it. But where he needed it, where it helped him, he used it there. So it certainly, people who think it diminishes the skills of the artist do not understand how hard it is. Because like today, my iPhone is over there. Like I go click, the entire scene's in focus, it's properly exposed. If you think that's what a lens does for you as an artist, no, then it does sound like they're cheated. But that's not what a lens does for you.
In fact, on that point, lenses in our cameras and our phones are very bad. Everything else, everything is in electronics and in the transfer image. But my question is, you've made a point here that you notice that optics was used when mistakes are made, quote unquote mistakes.
Yeah.
Do they always have to do with refocusing, or there are some other?
Oh no, there are other features.
Because you always talk about this refocusing thing.
Yeah, it's just in a finite length talk, it's impossible. I honestly could lecture for 8 hours. I'm not exaggerating on the different aspects of this.
So give us some example without necessarily the video accompaniment.
We'll have to show you images to do this. So I could show you other images and lead you through other ones. I'm not sure. I'm not prepared, so it'll take me a minute to find them. So.
But what about qualitatively? What other? So we've seen refocusing distortions. Are there other classes of distortions?
Okay, so there's spherical aberration, comma, the refocusing errors, if you will. There are segmentation. Like I've got, okay, I wish I weren't jet lag. Famous art, name a famous artist. Famous artist painted a picture, the portrait of a woman, and you can see jogs in the door frame that's behind her where he had to move the lens down because of field of view, which is not the same as the focus image. So that's another example of a type of error. Now, I'll answer a question you didn't ask. What about Leonardo? If there was anyone smart enough to use a lens, it's Leonardo. If it's anyone smart enough to cover his tracks, it's Leonardo. He covered his tracks in the sense of he didn't want you to know he used a lens, or just he didn't like the effects of that. So catalog of all of Leonardo's paintings, I go through, can't see a lens anywhere. Finally, I see the weakest evidence of the possible use of a lens. So I'm thrilled. Read the caption. We used to, this old painting is in this book only because we used to think it was done by Leonardo, but now we know it wasn't done by Leonardo, it was done by Ghirlandaio, and so that's the only reason why it's in the book. So I have found no evidence, and I've looked at every Leonardo painting, and can't find any evidence that he used a lens, which doesn't mean he didn't. It just, there's no evidence that he did one way or the other. The other thing is that every museum has 5% of their paintings on the wall and 95% in the basement. So if, using your word mistake, if these are mistakes in use of optics, it's more likely to be done by someone of lesser skill than a Leonardo, whose paintings are in the basement. So I started a collaboration with the Hermitage, and I was going to do a joint master's program between my university and the Hermitage. We had this thing all going, in case you don't read the news, there's reasons why this collaboration has ceased. But my real reason was, I to myself, called this a master's program in getting Charlie Falco access to the basement of the Hermitage. That's because I wanted to study those paintings. I wanted to look at those to see for more evidence of lesser artists, where I expect to see more evidence to be found of.
But you could do it in Metropolitan Museum. Every museum has.
You could, I mean, but you know, there's an amount of time.
Yeah, yeah.
Yes.
So I want to take a little tangential route from what you were saying, the backlash from the curators and so on, because it looks to me very similar to the debate that we are having now with artificial intelligence and machine learning in art and so on. But I mean, there are clearly things that, I mean, when you show the reduction of the image through the lens and then the reconstruction, that's a variational autoencoder that takes the image, does all the projection, and then generates another image. So I'm wondering if you have any thought about this environment, this new thing.
Yeah, it's a whole nother. We should talk about that in the pub. That's a long discussion of I'm all for it. But it's very interesting discussion. How artificial intelligence is going to enter into all of this as well.
Okay. I'm very convinced. I am convinced completely by what you say. One thing, great talk. What I'm interested in is the dimensionality. That almost everything you've done is a projection from 3D down to 2D. And at one point you said that engineering departments don't tend to have image processing expertise, which surprised me because we've got Professor Roberto Cipolla in my own engineering department who does. We've got a huge image processing, and a lot of what they're dealing with is. He's written a book with Peter Giblin, a singularity theorist from Liverpool, and it's all about 3D. So my question is, what about Bernini and what about the sculptors and so forth? Roberto works with Anthony Gormley, for example, and it does a huge amount of image processing, and it ends up with a sculpture, a 3D thing. And everything you said was a projection from 3 to 2. So Roberto's a fellow at the Royal Academy, I think, or a visiting professor there, and gave a talk there once. I was surprised that the students almost divided themselves into 2D and 3D sort of students. I was really quite surprised by this. Obviously there's time, but 3D and 2D. Everything you said was from 3 to 2.
Okay, that doesn't mean that everything I've studied has been 2D, and it doesn't mean that everything I've studied has been Western art. I think you said that I said something about you guys didn't use image processing. Somebody else must have said that to you.
I understood that, I apologize.
Yeah, no, it's my younger daughter's an architect, and so I know what they use also. And not to say it's exactly the same thing. It turns out that the camera lens, the problem the artist has is the artist sees a 3D world, and they only own canvas. So, well, the painters only own canvas. And so the problem that the lens solves for that kind of the painter is it provides a way, a really convenient way to represent the 3D world in 2D. Another talk I give is I call the tyranny of the lens. That also limits what an artist can do if they either directly or indirectly use optics. I've studied sculptures to try to see if I could. A lens doesn't really help, and so I can't tell you if any sculpture somehow a lens had been used. Yeah, there's no features that it would help, and I have no evidence that they used it. I've studied Islamic art to look for evidence in that, but a superficial job of studying Islamic art, I should say. But I found no evidence. This is an example where I can talk about a painting and say, and he did this and he did that, because I found no paintings thus far that were done by a female artist. So I don't have to worry about my pronouns. I can always say he when talking about the art. But if I estimate, if I had catalogs from all the major museums of Western Europe, the catalogs would be maybe that tall. We've analyzed that many, so there's much, much more work to do. But at some point, I figure I've shown you 6 equations, 7 unknowns. I figure the job is done. Somebody else needs to do that. I'll leave that open for them. But sculpture, I just don't know.
Okay, so we've got about a minute left for any final questions. Yes.
So can I just ask you about the social context of this? You seem to be implying that using lenses was always seen as a dirty thing to do, but the example you showed us with the carpet was a very small fraction of the canvas that used it. So was that used for prowess to show their ability with the medium, or was there a broader context, and did the use of lenses and the appreciation or acceptance of it change through history?
Okay, so here, let me firmly mark this as speculation on my part, because I don't know the answer to that. But I'll speculate that if I were Lotto and a rich, very wealthy businessman who's wealthy enough to afford one of those imported carpets came to me and wanted me to paint his portrait with his wife with this carpet that only he can afford, others can't. To the extent I can reproduce that carpet very realistically, I'm going to make a very happy client, and word will get out. So that's speculation on my part of why it was worth his effort. And I'll go one step further, since many of the men in here have gray hair. 20 years later, Lotto painted a similar composition, complicated carpet, husband, wife, all this kind of stuff, right where the lens would have gone out of focus had he used a lens. Considering how complicated it was, he put a great big silver platter. And there's this expression, age and treachery will always win over youth and enthusiasm. So I think speculation, he solved that problem as an older, wiser person would have solved that problem. Instead of going through all the effort of refocusing and lining things up and dealing with all that, which is really difficult.
All right. Thank you.
Okay, thank you.